unfortunately, I realized that the last live stream, the audio was not even working. And this happened one time before, and I thought it was just, oh, because my Bluetooth, this star projector is connected to the lamp. But it's not even that. It was disconnected this whole time.
Bluetooth is on.
It's 10:26. Wait, hold on. Man, no more solutions. Can you guys hear, by the way? Let me know in the chat if y'all can hear me. Because last time, I just gotta see. Testing? Okay. Thank you, Mello. Welcome to this chat. So, this is a regression analysis study session. I'm going over the previous exams. So, like midterm 1, midterm 2. And yeah, I guess I'll have to ask ChatGPT. Hopefully, I don't run out of uploads, but. No. Dang, someone is putting a lot of hearts. Thank you for the support, guys. Thank you. Does this go? No? Okay. I need to study for the final actually, final. And it's cumulative, so it has everything from these midterms in it. So let's go over each question and find the right solution and understand this time. Okay. Concept mastery review. We'll go over question by question, confirm the answer, and most importantly, why it's correct. I'll start with question 1, A, B, C in the message, and move on to question 2, 3, 4 after. So question 1, alright. Let's look at this. How can you... Oops, sorry, no singing on stream. Okay. So question 1, multiple choice, no explanations required. Select one answer for each of the following parts. Clearly write the letter of your choice in the bracket at the end of each question. Please note that if you circle the correct solution without writing the letter in the given space, blah blah blah. Okay, in simple linear regression, consider the underlying model y equals beta 0 plus beta 1 x plus epsilon, where epsilon is the error term. When trying to estimate beta 0 and beta 1 using the least squares method on a sample, which of the following is true about the assumptions for the error term epsilon? So this one is easy. Hello, Ethan Church. Welcome to the stream. Thank you for tuning in, guys. I really, really appreciate everyone who's in the stream right now because it does motivate me to study more. And I really need to study, guys. This is crazy. But yeah, I know the assumptions for an error term is the mean has to be, well, I'm gonna write this down actually. Never mind, I don't have my paper. Okay, 1 second, guys. I'll go grab a piece of printing paper and write down some important notes. Alright, I'm back. So, I have a paper here. And, okay. Let me put these things away so I have more space to work. Okay. So, we have assumptions, or yeah, I think assumptions for epsilon. Because he did like a review for the final, and he said the first question is going to be assumption for epsilon in more detail. So these are the assumptions. We have normal. All right. So what? 4 assumptions on error terms. Number 1 is normal. Number 2, expectation 0. Number 3, same variance for all I. And number 4, independent. All right, so E is independent with X. Oh, okay, which of the following is true about the assumptions for the error term? E. E is dependent. That's not true. We know it's independent. Number 2, follows the normal distribution. Yes, it's normal. Can have an expectation any. No, it has to be 0 and can be reduced to 0 with improvements. It cannot be 0. So, yeah, B is the obvious answer here. Okay, part B of number 1, in multiple linear regression. In the general form, like we have seen in class, it is very important to be able to identify the matrix form of regression, i.e. identify the terms in y equals xb plus epsilon, where epsilon is the error vector. In the advertising dataset, we would like to find the relationship between sales, the response variable, and the other three explanatory variables: TV, radio, newspaper. The first three rows of the dataset is provided. Based on the provided data, what should the matrix X be? Alright, so if it's in this format, y equals xb plus epsilon, then this is y, this is x. No. X is this, right? I put D. Oh, no, yeah, 1 has to be the first column. Okay, that makes sense. Miguel Otero, welcome to the stream. Hello, thank you for joining. So yeah, 1 always has to be in the front. So I got that answer right on the midterm. So when B matrix form of regression, you were told response variables, sales, predictors, TV, radio, newspaper. First three rows of the data. In matrix regression, first column all ones is the intercept. Okay. Okay, so first column is always 1 for the intercept. Number 2, then the predictors only, never include y sales inside x. So response variables is y, right? Well, yeah, because y is the response. All right. Response variable equals y. All right. Explanatory variables are x. Predictors. I don't know why they use so many different words. Like, I don't understand English, bro. Explanatory variables. Oh, I'm cold. I'm Vecna. Explanatory variables equals predictors, which equals x in it. What should x contain? No, not x. Equals minus intercept. I guess. I'm gonna confuse myself, bro. Okay. Explanatory variables. So in this case, it's sales. Oh, not sales, bro. Newspaper, TV, and radio. So, never include inside x. Alright. Never include response variable in x. So x here would be equal to 1, 1, 1, 1. And then sale. Oh my gosh. TV, radio, what? And newspaper. That would be x. So, yeah. 3 by 4. Looks good. Okay. Now, part B. Hello, Victoria Hooper. Welcome to the stream. Thank you for tuning in. And I hope you're studying as well alongside for your own final if you have one. If you don't, then that's really kind of you to stay and watch me. So this is part A of midterm 1A, 1B. Alright, so next we have part C. Consider a version of simple linear regression. Let's see, no intercept regression slope. Consider a version of simple linear regression without the intercept, i.e. with underlying model y equals beta 1 x plus epsilon, where epsilon is the error term and follows inappropriate assumptions. Give a sample size n, x1, y1, x2, y2, the rest. What would be our least squares estimator, beta 1, of the true slope coefficient in the current slope only model? Simple linear regression without intercept. Without intercept, y equals beta 1 x plus epsilon. Give a sample size n. What would be our least squares estimator? Of the true slope coefficient in the current slope only model. Least squares estimator of beta 1. Well, I guess you're just gonna have to memorize that formula then. Beta 1 hat equals sigma, no, it's not sigma, summation n I equals 1 xi yi all over summation of n I equals 1 x squared I. So the correct answer is C. What, D, bro? That's because that was a formula for something else. That was for another beta 1, but this is for least squares estimator without an intercept. Maybe this is with an intercept. Yeah, I'll put with intercept. After Thanksgiving break, literally everything left my head. And why? Actually, nothing was even in my head, if I'm being honest. Oof. Writing the wrong things now. Xi squared minus n I equals 1 xi squared over n. So this is with intercept. Alright. This is the mean of y, wrong structure. And then I'm just gonna put this like in case they ask what is the mean of y or something. Y I over n equals mean of y. So this is the correct formula. Next level. Yes. Let's do question 2A. Question 2A, compute the slope estimator beta 1. Okay, so I think we're done with this page of the midterm. That was the simplest one. Now, this is where it gets hard, guys. Because oh. Alright, no fines concrete is beneficial in areas prone to excessive rainfall because of its excellent drainage properties. The article pavement thickness designed for no fines concrete parking lots, J of Trans Engineering, provides data on unit weight denoted as X in PCF and porosity denoted as Y, meaning having holes through which liquid of air may pass, in percentages. We want to study how porosity, response variable, is related to unit weight, X independent variable. We want to do so by using simple linear regression on the database based on least squares, i.e. fit a model y hat equals beta 0 hat plus beta 1 x, beta 1 hat x. Below are results of the regression. So this is beta 0 hat, this is beta 1 hat, this is p-value x. Okay, so this is the RSE, r squared, I just did r squared, f statistic, p-value, degrees of freedom. Here are the, please compute the slope estimator, i.e. compute beta 1 hat. So this one has an intercept. That means we used the formula that we wrote up here, right? So I did that, right? Yeah, I did that. This is the most important slope formula for your final. Did I write that same thing here? Why does it look different? This is so complicated. I would rewrite this as this. Let's see. This is 2A. Um, compute the slope estimator beta 1 half. Okay, so simple linear regression model. Y hat equals beta 0 hat plus beta 1 hat x 2. Alright, not here, let's go here. Rewritten simpler, beta 1 hat equals summation xy minus summation x times summation y all over summation x squared minus summation x squared over n. Both over n. Oh my gosh. Alright. So this is formula for slope with intercept. Simpler written formula for slope with intercept. Alright, step 1, compute the numerator. So, I don't know if I should write down these steps or just do it here by myself. Let's see. X equals... I do not want to do this, man. I should probably do it though, just for practice. We are Charlie Kirk. Wait, I can't find my calculator. Ugh, this sucks, man. Alright. I guess we'll just have to wing it if this question comes up, because I don't think it will. If it does, that's gonna be so annoying. Because literally the final is 4 questions. And you have to study everything because it's cumulative. You don't know what's gonna be on there. If I had a practice final, which some professors do have, that'd be so helpful. Like, if you want someone to actually study, give them a practice final. Let them know what's gonna be on there. Not just study everything, that's too much. It's overwhelming. Okay, so that's the answer you get. Please compute the intercept estimator. Compute beta 0 hat. Alright. Computing beta 0 hat. Intercept estimator. What is this? 2B? This pen is giving out, bro. Let's find a better one. This is nice. Alright, so what is the formula for beta 0 hat? How come I got a different answer than ChatGPT? Huh. So, can you basically calculate beta 1 hat by subtracting this value from 1? Because if that's possible, why go through all of this, bruh? And I fully understand the formula sign logic. For question 2a, this is the answer. Wait, what? How come this is the final answer when you literally calculated this final slope? That's weird. I don't understand that. Hold on. Alright, so before we continue, I want to understand why the answer would be, what would it put? Negative 0.04109 if you yourself computed another thing though, like the value you got was negative 0.966, right? So why did you change that? Also, I also only have 4 uploads for this, so I have to make sure not to talk too much. And I'm glad you caught it. Let me clear this up clean and honestly, because exact confusion can cost points on a final if it's not resolved. What happened? You were 100% right about this. Using the number exactly as I typed in, we got the output in your exam clearly says this. So why did I switch to this? Because the R output is authoritative correct value, and the handwritten scan summary stats number must contain a type or scaling error, especially in sigma or summation xy. This happens a lot of scan exams, handwritten notes, or copied summary stats table. Let's prove the summary stats must be slightly wrong. To reverse engineer with the numerator must be to give this. We are trying Wait, why I trusted and not this? The t value, the computed slope, the r output, the physics, real world meaning. The logic was correct, confusion was completely justified. So, fully fix the foundation level. Okay, let's do question 2. Okay. Let's do 2. Compute the intercept beta 0 hat. Beta 0 hat is y bar minus x, and beta 1 hat x bar, where x bar is this and y bar is this. So, let's see. This is what finals love. When unit weighs 0, the predictor's porosity is about 24.45%. Okay, but the intercept is still mathematically necessary to anchor a regression line. Mean based intercept formula. I'm tired, guys. I'm studying for 36 minutes. But I'm only like on question 2. I didn't even finish question 2. That's like half the midterm, I think. I'm gonna stream so much over these next few days because there's a lot of studying content. This is what I live for. And I'm still gonna study after my exams. I'm not gonna stop, okay? I have enrolled in an Arabic class. Not Arabic, Islamic basics class. It might be too easy though, I'm not sure. But yeah, I hope to learn Arabic when I have free time. But I should focus on this right now. So computing beta 0 hat, the intercept estimator, we have the formula beta 0 hat equals y bar minus, sorry, y'all gotta see what I'm doing if I'm streaming it, minus beta 1 hat x bar, where y bar equals summation x over n, x bar equals summation y, wait, no, this is y bar equals summation y over n, right? Simple. Pretty straightforward there. Can't go too wrong. So essentially what beta 0 hat is summation y over n minus beta hat 1 summation x over n. There you go. That's the formula. And then you compute it like so. And you plug it in. Where you found beta 1 hat is the correct R output value. But why did I get something so different? This doesn't make sense. Even ChatGPT got something different. Should I ask another AI or something? How? Okay. Let's ask Mr. DeepSeek. No, my screenshot went away. When calculating beta 1 hat, does it have to match the beta 1 hat in the R results of the regression? If so, how do you get it? Cause listen, what ChatGPT got was negative of what this says. So is the standard error like an absolute value or something? I would ask ChatGPT, but he has like limited conversation. I don't want to use all of it. That's literally what I got. This is very different. Alright, hold on. So let's compare the data you have with the regression results given. First, check the table for R from the R output. Okay, the t-value formula is t equals beta 1 hat over standard error of beta 1 hat. which is this. But wait, the t-value signs being negative while the estimator is positive means something is inconsistent. So it doesn't have to match the R output, right? Correct. It does not have to match the R output if the R output table contains an error, as appeared to be the case here. What? What? That doesn't make sense. Why would that be an error? Like, I don't know. I would have to ask. I think it's too late to ask my professor this one. Doesn't make sense. But the R output table was estimate for X, which is actually the standard error, since that divided by that is this. So the R output system swap the estimate and standard error values for the X coefficient row by mistake. In your answer, you should use the provided sums to compute beta 1 hat correctly. But the mismatch of the table explains why, likely a formatting error in the table. Report as your computed slope. Okay. That's weird. Please compute the intercept estimator, i.e. compute beta 0 hat. Okay. I want to see what I got for this question. What was this? The term 1, 2, 8 out of 10. I think because I got C wrong. Yeah, it's part C. For 2 points here. Everything was right except for C. I don't know why I put greater than. It should be not equal. That's the easiest thing. Big C. Alright. Yes. Let's go. It's all about understanding F-test, and once this clicks, 3 to 4 other exam questions become 3 points. Question 2C, interpreting the F-test. I got my cats in the back. Okay, so from the R output, you were given F statistic p-value 1.125 times 10 to the negative 11th power. This is for F stat. How do you know it's for F stat? Oh, it's right here. Okay, so this is for the F statistic. This is for the overall regression model. The model is this. I mean, it doesn't have epsilon in the picture, but okay. Clearly state the null HO and the alternative H1 hypotheses in the context of this question corresponding to the p-value. So what is the F-test in simpler linear regression? The F-test is testing the slope. That's it, no tricks. It is testing, does explain it. Exam perfect answer. Null hypothesis, porosity has no linear relationship with unit weight. Alternative hypothesis, porosity does have. So decision using the p-value. Given p-value equals this, since p-value is less than 0.05. Wait. Why would you choose 0.05 though? Did it say where? It's like a. I think I put greater than because how could it be less than? Or, yeah, like how could it be less than? You can't have less than that. Can you? Alright, let's ask Mr. Wise. Alright. Okay. So if we do a hypothesis, an F-stat hypothesis, so how do you test the p-value? And how do you know to check if less than 0.05 than any other number? P-value and significance. I'm tired. I'm tired of studying, man. It's 2B, right? So F stat hypothesis test. Two C. F stat equals 1.125 e to the negative 11. So HO equals HO is beta 0 equals 0? Wait, what did ChatGPT say? Beta 1 equals 0. Not beta 0. Bruh. Because this is... HO, H1. What does DeepSeek say? HO, HA. So... Okay. HO is right. I put HO and then I put H1. I was right for the most part. Why did I get both of them wrong though? Alright, well. After this question, maybe I'll take a break and then resume streaming later. We'll see. I mean, studying for an hour straight is good. It's a good start. We have 12 hours in a day. It's only 11 a.m. I don't know what to do between this though. Like, I can't even eat, Bill. I'm fasting. Okay, so. Put it in simple linear regression. T-test for beta 1. Often 0.05 by convention. Alright. So it's just by convention that you check. Since 1.125 e to the -11 is less than 0.05, reject HO. What is the conclusion? We reject the null hypothesis and conclude that it is a statistically significant predictor of porosity. Sorry. He's not used to me writing. I'm usually like reading, and that doesn't disturb him while his head is sleeping here. But he likes to participate in studying. This is nice because you can't tell my bed is unmade from the other side. We are Charlie Kirk. Okay. Conclude that the unit weight is a significant predictor of porosity. So the thing to remember here is, and I'll put it here to the side of the question. Wait, where was it? Where was it? Oh, I think it was over here. Alright. If p-value Alright. One-sided hypothesis testing the same output. Okay. How come no one's joining the stream anymore? Hmm? 3a, b, c. So 3a, one-sided hypothesis test for the slope. One-sided hypothesis testing test for the slope. Alright. So, we're still looking at the same regression model. Select one answer, clearly right. Following parts are based on the same situation information as previous questions. No finds concrete. We are interested in knowing whether there is a significant negative relationship between unit weight and porosity. To investigate, we test given the intercept HO, meaning beta 1 equals 0, versus H1, beta 1 is less than 0. What is the p-value for this hypothesis test? HO, where beta 1 equals 0, H1, where beta 1 is less than 0. So this is one-sided, it's only on the left side. So p-value equals what? What is the p-value for this? So let's say like if you have like a normal distribution and your average or your normal go-to p-value is 0.05, then half of 0.05 would be 0.0250, right? What p-value? Let's have well, it's okay to guess, but the finals, I hope you very, very good luck. Thank you, Primal, and thank you for showing up to the stream. Like you are my most loyal subscriber. Or like viewer. I don't know if you subscribe, but step 1, read the question's wording carefully. The key phrase in your exam was test whether porosity decreases as unit weight increases. Wait, did it say that? Okay. The phrase decreases as x increases implies a negative slope. Therefore, it's a left-tailed one-sided test. Well, I could tell that just by the sign here. Like, it's pointed towards the left. It's 0 or less. So write the one-sided hypothesis correctly. It's the most important part because there's testing for decrease. Hypotheses are, or sometimes written as beta 1, greater than or equal to 0. Oh. If it's written as this, I can't tell. It's one-sided. So, let's see here. Well, if you want to know what the negative relationship, then you already know it's negative from the given. I have to like this one. Thank you, Primal. How's your day, by the way? Did you learn about new planets or something? Alternative hypothesis, left-tailed testers. Inwards does not. Does. convert the two-sided p-value to one side. Two-sided p-value is this. And then you divide that, you get this. Make a decision. Oh, so this thing is still the same, but the p-value itself, the value is... I was dividing this part, not this part. Okay. So we reject HO. We already rejected it from before. If it's even smaller, then it has to be rejected. I have to... Yes, I learned one plan. It was P22B. Or just 22B. Oh, really? That's cool. What is it? What is... It's like Jupiter? Wow. Let's see. Let's look it up then, shall we? 22B planet. Kepler? It's green. Wow. I can't believe this actually exists. I think you've told me about this one before, though. It's like Jupiter, huh? I mean, I feel like I've heard about Kepler, but I'm not much of a astronomist or like astronomy fanatic. So, yeah. I feel like you told me about it before. Or did you learn about this recently? Is this another Kepler or the same one? The p-value given... Okay, so p-value. So for this... It was supposed to be B. Alright, so the p-value given is this. 1.125. Let's look at the table again. Where does it say 1.125? Oh, this is 1. This is what the R thing is. 1.125. The F test. Okay. How do you know they're still doing an F test though? Sorry, I'm eating Indian food right now. My mouth is burning. I gotta go. Alright, take care. Hope your mouth calms down. Yeah, Indian food is really spicy. Okay, so... How do you know the p-value is supposed to be... If they didn't say it's supposed to be an F test, or do you just think it is based on the last question? If it hadn't said F test that and gave you just a p-value and regression output, you need to check whether it's for t-test for a specific coefficient appearing next to the coefficient estimate, or F test for the whole model, usually at the bottom of the output. The R summary at the bottom of the board. That's the is p-value referring to here. Okay, because if you look at it, there's p-values up here too. Because there's other p-values, like, and what was the other one? So that's confusing. Exactly, that's a common point of confusion. Here's how to distinguish them in the given table. For intercept, p-value, this is a t-test p-value. For HO, beta 0 equals 0. For this is the t-test for HO, beta 1 equals 0. Same hypothesis as F-test in simple regression. At the very bottom, is an overall f-test p-value for h o beta 1 equals 0, same as null as t-test for x in simple regression. So why p-values are the same hypotheses? In simple linear regression, f is t squared, and both p-values will be identical if calculated exactly. They differ slightly because of rounding. So okay. Not the individual t-test p-value. Okay, so this was itself not even the f-stat. So I don't know why I put that. 1.125e negative divided by 2 equals 0.56e to the negative 11. Alright, that was 3a. So 3b. Alright, what proportion of the variability in y porosity can be explained using the regression model? Sorry, I'm just taking a little break right now to just zone out, I guess. I don't know. Alright, 3b. What proportion of the variability in porosity can be explained using the regression model? Variability in x. Okay, next. TV. Why is he being... Oh, this is DeepSeek. I thought it was ChatGPT. Yes, let's go. Yes. Let's go. I could stream for 8 hours straight at this point. Because I gotta study hard. I need to compute the SE of the slope. So far, the final review has nothing based on what I was studying from the midterm one. But I don't regret it because I mean it is a little discouraging because it's been a lot of time. But I just want to make sure for my to-do list here that we go over, let's say, midterm 1, midterm 2, um, final review, probably some homework, like the take-home exam. I don't know. That's just coding. You guys ever like look up your exam? Anyways. Okay, I think I'm done.